Dear students, in this video, I'd like to explain Chapter 9 regarding correlation and regression. First of all, let's start with the uh, simple linear regression model. We have example 2. This example we have done in theory class. Now we will do it using RStudio. The data of this example is saved in the file name called Steam. You can download the file. So the first question was how to draw scatter diagram. In order to draw the scatter diagram, you need to see the file. First of all, the file, if you open it in RStudio, you will see that we have an X, which was in the theory class. The X was what? The temperature, and the Y was the consumption of water steam. So the command used to plot a scatter plot is plot. First of all, in order to extract the variable or the column you have in this file, you need to write the file name, dollar, select X, and then file name, dollar, select Y. You will get your output in the plot window. So if you observe from the plot, you can see that we have the relationship between X and Y is linear and it's negative. In order to measure the strength of the relation or linear relation between X and Y, we need to calculate the correlation coefficient. So to calculate the correlation coefficient, we need to use the command core. So write the file name. Here it's optional. You want to write X first or Y. The correlation coefficient will be same. Select X, comma, file name, select Y. So the correlation coefficient value, we get it as minus 0.90, which indicate that there is strong positive correlation between steam consumption and water and the temperature of the atmosphere. There is another command we can use. If we write core and the file name, we will get a correlation matrix. So it's up to you. You want just to get the value of the correlation between X and Y, or you want to get the correlation matrix. And from the correlation matrix, the correlation coefficient between X and Y is visible. That was the answer for question B in theory. To fit a simple linear regression model between X and Y, we need to find the intercept and the slope. In R, we have only one command, which is LM, linear model. First of all, as you did in ANOVA, in linear model, you will do the same thing. First, we will select the response variable, Y, tilde, steam, dollar, the independent variable, X. After running the code, we will get the value of the intercept, 14.3. So the equation is Y equal to 14.33 if we approximate it to 2 decimal places. And the slope, of course, the slope will be negative 0.089x. Okay, if you want to get the model fitness, the R-square value, and more information about this linear model, you can use the code summary and put the previous code inside the summary command. So this will give you more information about the simple linear regression model. From this information, it is useful to know the R-squared value because R-squared tells you about the model fitness. The higher the R square, the better the model is, because R square explain the variability of the model. I mean, explain the variability of the response variable explained by the model. So the last question here was estimate the consumption of the water stream. We want to estimate Y if the X is 45. So let's find that one. 14.33 minus 0.089 times 45. Use R as a calculator to predict the value of Y. So the estimated value of Y is 10.325. This is regarding simple linear regression model. What about multiple linear regression model? Multiple means you don't have only one X, you have more than one X. So there are many independent variables. In that case, we use multiple linear regression model. We have one example here in the theory class, which was about salary. Determine if the salary was related to the year of experience and score on the programmer aptitude test. First question was compute the correlation coefficient between the variable salary and experience. The second question was fit a multiple linear regression model of salary. So salary is the response variable or the dependent variable Y, and the other two variables are score and experience. These are your X variables. So the file name here, we have saved the data of this in a file name called salary. Download the file. And now let's answer the first question. Compute the correlation coefficient. The same command you have used before, you use it again. So the command is core, write the file name. It gives you the correlation matrix. We want the correlation between the variable salary and experience. So from the correlation matrix, you can see the correlation between salary and the second variable was experience, salary and experience. So the correlation is positive, strong between the salary and experience. If you want only to get the correlation, display only the correlation between these two variables, you can just select these two variables only. So like this one. So the program will display only the correlation between the salary and the experience. Similarly, if we want to find the correlation between the correlation coefficient between the variable salary and score, we can just see it from the matrix. Salary and the score, they intersect at this value, 0.75. We can say the correlation is again positive between the salary and score. Fit a multiple linear regression model. The command we use here is again the same command we have used before. So the command is lm, file name, $. From the data frame, we have 3 columns. The first column is experience, the second column is a score, the last column is a salary of an employee. So that is your Y. So first we select the Y, press tilde, then select your X. No matter which one you select first, the model we will get same. If we select experience, then we have to add and choose the second X. Again, file name, $, choose the second X, here is score. When you run, you will get what? You will get an intercept since we have two independent variable, two x's, x1 and x2, so we get two slope. 1.4226 is the slope for the variable experience, and the second one is 0.4997. How do we write this equation? Linear equation, we write it as y equal to negative 14.1192 plus 1.4226 times x1 plus 0.4497. How do we interpret those slope, or how do we interpret this equation? In order to interpret this equation, you need to interpret the value of the slope. So how do we interpret the face value of the slope? We said, as we did in the theory class, let's show you. So for the first one, we will, when we say the slope is equal to 1.4426, it means that for 1 unit increase in x1, x1 is experience, y will increase by on average of 1.4226 units, assuming the other variables are constant. Similarly, we can interpret the second slope. For the second slope, the value was 0.4497. So we will say for 1 unit increase in x2, y will increase by on average of 0.4497 units, assuming the other variable are constant. That's regarding this multiple linear regression model. Thank you.